Alaikum warahmatullah. Hello everybody. In this session, inshallah, we are going to discuss the second part of the practical biochemistry. As we know, every time we are going to discuss the concept map. We have discussed bioinformatics, the biomolecules lab identification, diffusion, dialysis, and osmosis. And in this practical session, we are going to have two topics. First one, which is expression of concentration. The second and the final one, or the final part in the practical, will be pH and buffers. First, expression of concentration. What is ILOs of expression and concentration? First, we are going to determine how to apply different methods for expression concentration. Then, we have to determine measuring weight and volume, preparing a molar solution, perform different solutions, dilutions from stock solutions. First, we are going to identify what is a solution. Solution, it means that it is a mixture. Solution is a mixture. Mixture of what? It's mixture of two substances. The first one is called solute. It's called solute. And the second one is called solvent. So, what is solution? Solution is a mixture of two substances. The first one, which is solute, this solute is the dissolved part. Dissolved part like sugar, like salt, then it is called solute, or the substance that will be dissolved. The second substance, which is solvent. Solvent, it means the substance that will dissolve the solute. Then solution is a mixture of solute and solvent. Solute will be the material that will be dissolved, or the particle will be dissolved, like salt or sugar, while solutes are the substance that will dissolve these solutes, like water, like alcohol. Later on, we are going to discuss these solvents. So, what about the concentration of solution? Concentration, it means the amount of solute dissolved in 1 unit of solvent. What's meant by concentration? Concentration, it means the amount of solute dissolved in unit amount of solvent or solution. Shall we see these three beakers down in the slide? The first beaker on the left side, here it is the blue particles. This represent the solvent, while the red particle represent the solute. Here, for example, if we mention that these red particles, which are solute, represent teaspoons of salt, then I have here 2 teaspoons of salt present in a solution. Then this solution is diluted, or it contains less solute. In the second beaker, here the number of solute or the number of salt particles is increased. By increasing the number of solute, here the concentration will be increased. In the beaker on the right side, here the red dots, which represent the solute, are markedly increased. By increasing this amount of solute, then the concentration will be increased. So, if I ask you which solution or which beaker have the highest concentration, the highest concentration will be the beaker present on the rightmost side, as it has more solute. And which has the least concentration? The least concentration, it means that the solution that have the least amount of solute. The least amount of solute are present in beaker number 1, or the beaker present on the left side. Again, what is concentration? Concentration is the amount of solute dissolved in unit amount of solvent or solution. How to express concentration? Concentration is expressed in two ways. The first one is qualitative. Quality, it means this solution is diluted or concentrated. Quality, it means or can't answer question in numbers. Quality, it means for concentration, it will give an answer if it is diluted or concentrated only. But the quantitative expression of concentration, quantitative quantity, it means that it will give the value of number. So expression of concentration is divided into two parts. First one, which is qualitative. Qualitative, it means, or it answers the question that this solution is diluted or it is concentrated. How I know it is diluted or concentrated? I know it is diluted or concentrated from the color of the solution. What's meant by diluted? Diluted solution, it means that the amount of solute is decreased or less in relation to the solvent. What about concentrated? Concentrated, it means that the amount of solute is large in related to the solvent. Diluted and concentrated is the expression for qualitative. Qualitative. What about the color of the solution? The diluted solution have light color or pale color, but concentrated solution have darker color. What about the other expression of concentration? The other expression of concentration, which is quantitative, it will give numerical expression, and we are going to discuss what these numerical expression and what are these items. Here, for the qualitative, we mentioned that the expression of concentration that will be represented in qualitative method, it will be represented by colors. Here are different beakers. The darker in color, or the darker one, the one on the most left side, is more dark. More dark, it means that it is more concentrated. The middle one is light purple. Light purple, it means that it has less concentration than the most left side. Look for the beaker, the paler one on the right side. This is the most diluted. Most diluted, it means it has the least amount of solute, but the one on the left side, most left side, it have the most amount of solute. And the middle one have moderate amount of solute in relation to solvent. What about the quantitative or the numerical? The numerical expression method, I have to know two methods. First one is percentage, and second one is molarity, percentage and molarity. And we are going to discuss each item separately. First, percentage. Percentage means the amount of solute 100 part of solution. What is meant by percentage? Percentage, it means the amount of solute that is dissolved in 100 part of solution. So if we express it mathematically, what will be the equation? Equation of percentage equal P, or percentage equal the amount of solute divided by 100 part of solution. Again, can you remember what is solution mean? Solution is a mixture of solute and solvent. Then what is percentage? Percentage, it means the amount of solute divided by 100 part of solution. And here solution is the addition of both solute and solvent. Again, can we subdivide this percentage? Yes, percentage can be divided according to the type of solute. Here, I mean the definition of percentage again is the amount of solute dissolved in 100 part of solution. If the solute is divided into two parts according to its nature, the first one, which is liquid, when the solute is liquid. The second one, when the solute is solid. What will be its expression? Here, the percentage will be in solute, when the solute is liquid, then the expression will be volume per volume. Volume per volume percent, or V per V percent. What about the percentage when the solute is solid? When the solute is solid, then it will be, the solute will be a mass or a weight. So it will be expressed weight per volume percentage or W per V percentage. W per V percentage. Can you give me an example for solute to be solid? Yes, it's an easy one. When I'm going to put salt in water or to put glucose in water. Here in medicine, we have a solution called glucose solution. Glucose solution, glucose is a solute or solid solute. This solid one can be expressed in which expression? Here, as glucose is solid, then it will be expressed in weight or in a mass. So it is weight per volume. Weight per volume percentage. So glucose, what is the percentage of glucose solution? It will be 5 gram percent. 5 gram percent. Glucose 5 gram percent means that I dissolve 5 grams of glucose, which is represented in weight, in 100 milliliter solution. 100 milliliter solution. Then glucose 5 gram percent, it means that I dissolved 5 gram of glucose in 100 milliliter solution, and we get that solution is the addition of solute and solvent together. What about the solute when its nature is liquid? When the solid nature is liquid, then it is volume per volume percent. For example, this example for this volume per volume or V per V percent is what? Is 70% ethyl alcohol. As we know that nowadays we have corona, and 70% ethyl alcohol is considered as one of the disinfectants. So how could we prepare this 70% ethyl alcohol? We know that alcohol is liquid in nature. How to prepare 70% ethyl alcohol? I'm going to have 70 milliliter of 100% alcohol and complete it to water by 30 milliliter to get total solution 100 milliliter. Here, for example, the solute is liquid. The solute is liquid. Liquid, for example, of what? For ethyl alcohol. What is the percentage of ethyl alcohol? I have here 70% ethyl alcohol. 70% ethyl alcohol, it means that I get 70 milliliter of 100% alcohol. Then I'm going to complete it with 30 milliliter water to get 70% ethyl alcohol. 70%, it means that it is 70 milliliter of ethyl alcohol present in 100 milliliter total solution. Again, percentage, it means the amount of solute dissolved in 100 unit of solvent. 100 unit of solution. Solution, it means solute plus solvent. Here, the percent will be subdivided according to the solute. The percent per volume or the percentage should be divided according to the nature of solute. When the solute is solid, then it is expressed in mass or weight. It is W per V percent or weight per volume. For example, it is glucose 5 gram percent. And when solute nature is liquid, then it is expressed as volume per volume percent or V per V percent, like 70% ethyl alcohol. How to calculate the concentration in percentage? Here, when it is volume per volume percent or V per V percent, then it means the amount of volume of solute in milliliter divided by volume of the solution multiplying by 100. V per V percent. How to calculate it? I'm going to calculate or make an equation that represents volume of solute measured in milliliter divided by volume of total solution expressed also in milliliter multiplying by 100. What about the percentage when it is expressed weight per volume or W per V percent? W per V percent, it means that the mass of solute in gram divided by volume of solution in milliliter multiplying by 100. Again, V per V percent, it means volume of solid in milliliter divided by volume of solution in milliliter multiplying by 100. And about weight per volume weight per volume or weight W per V. It means that here the solute is mass, then mass of solute in grams divided by volume of solution in milliliter multiplying by 100. Again, solution is the addition or the total amount of solvent and solute together. Shall we have different examples or how the exam could be? Here, an IV solution is prepared by dissolving 25 grams of glucose in water to make total 50 milliliter solution. Here is a solution. This solution is composed of dissolving 25 grams of glucose. Here, as the solute is gram, so it is solid and it is weight and measured in gram. Make total solution 50 milliliter solution. So what will be the weight per volume? The weight per volume percent, I'm going to divide the amount of solute, which is 25 gram, divided by total solution amount, which is 500 milliliter, then by dividing 25 by 500 multiplying by 100, it will be 5 gram percent. So here he asked what is the weight per volume of glucose in this IV solution. The answer will be weight per volume or W per V percent equal mass of solute in gram divided by volume of solution in milliliter multiplying by 100. Then 25 dividing by 500 multiplying by 100, the answer will be 5. Yes, the answer will be 5%. Here, how much solute is present? How much solute? Here, the question will be the amount of solute is present in 756.1 milliliter. This is the total solution of 14.7%, and this is the percentage which is the mass per volume. Again, he asked how much solute. Here the amount of solute is unknown. He given here the total amount or the volume of solution, which is 756.1 milliliter, and he give here the concentration or the percentage, which is mass per volume, and it's expressed as 14.7%. Here the equation that we are going to solve with is W per V or mass per volume percent equal the mass of solute in gram divided by volume of solution multiplying by 100. Here the mass per volume will be replaced by 14.7, and here mass of solute in gram is unknown or will be expressed an X or question mark, and the volume of solution is 756.1. By making cross multiplication, or I have mass solute which is X, then I'm going to multiply mass of volume percent multiplying by volume of solution in milliliter dividing by 100, or making the scissor technique. Here 14.7 gram or 14.7% would be multiplying by 756.1 and dividing by 100, the answer will be 111 gram. Then the mass of sodium chloride or the amount of solute dissolved in this solution to make 14.7% is 111 gram. Another example, how many grams of salt are there in 52 milliliter of 6.3% solution? Here again, he asked about the grams. So when he asked about the grams, then the equation would be expressed in weight per volume or mass per volume percent. Mass per volume percent equal mass of solute divided by volume of solution multiplying by 100. Mass per volume will be replaced by 6.3. Here the mass of solute is X or question mark. The volume of the solution is 52 milliliter, and here multiplying by 100. Then the mass solute will be or equal to 6.3, which is mass per volume, multiplying by 52, which is a volume solution, divided by 100. Then the mass, or X, the mass solute will be 3.276 gram. 3.276 gram. Another expression for concentration. Again, we express the concentration in two ways, qualitative and quantitative. Qualitative, it is diluted. Diluted, it means small amount of solute present in a solution. And concentrated, it means large amount of solid present in solution. Diluted is pale in color. Concentrated is deep or dark in color. For the qualitative or the numerical expression, we have finished percentage. And now we are going to talk about the molarity. First, before talking about molarity, what is meant by the molecular weight of any substance? What's meant by the molecular weight? Molecular weight of any substance, it means the sum of the atomic weight of all atoms present in the formula. For example, I have a substance which is sodium chloride. Sodium chloride. What is the molecular weight of sodium chloride? To get the molecular weight of the sodium chloride, I am going to get the sum of the atomic weight of each atom separately. Here for sodium, what is the atomic weight of sodium? The atomic weight of sodium is 23. What about the atomic weight of chlorine? The atomic weight of chlorine is 35. So, the atomic weight or the molecular weight of sodium chloride will be 23, which is the atomic weight of sodium plus 35.5, which is the atomic weight of chlorine. It will be 58.5. Then 58.5 is the molecular weight of sodium chloride. So, can we remove molecular weight and replace it by a mole? A mole, then the molecular weight is or can be expressed in the form of a mole. So again, what is the molecular weight? Molecular weight is the sum of the atomic weight of all atoms present in the formula. Here for sodium chloride, the molecular weight of sodium chloride is the summation of the atomic weight of sodium, which is 23, plus 35.5, which is the atomic weight of chlorine. Then their sum will be 58.5. The molecular weight of sodium chloride, which is 58.5, can be expressed as a mole of sodium chloride equal 58.5. So, what is a mole? A mole, it means the molecular weight of substance in gram. So, what is mole? A mole is the molecular weight of substance in. Again, here, what is a mole? 1 mole or a mole of substance is the molecular weight of substance in gram. Can I give you an example here? It is sodium phosphate. Sodium phosphate. Sodium phosphate, what is the molecular weight of sodium phosphate? Here the molecular weight of sodium phosphate. First, what is the different formula or what is the parts of the sodium phosphate? Here, sodium has only one atom. And what is the atomic weight of sodium? The atomic weight of sodium, we mentioned in the previous slide that it is 23. Here, hydrogen. How many atoms of hydrogen are present? Here is H2. H2, it means that I have here two molecules of hydrogen. 2 molecules of hydrogen. Then the atomic weight of these 2 hydrogen is 2 multiplying by 1. 1 is the atomic weight of hydrogen. Then 2 multiplying by 1. For P, phosphorus. Phosphorus here is 1 atom. Then the atomic weight of P is 31. And for O, it is oxygen. The atomic weight of oxygen is 16. And I have here 4 atoms of oxygen. Then I'm going to add the atomic weight of 1 sodium and 2 hydrogen, 1 phosphorus, and 4 oxygen. 4 oxygen. Then 23 plus 2 multiplying by 1 plus 31 plus 4 multiplying by 16. Then the total atomic weight will be 100. So the molecular weight of sodium phosphate will be 120 grams. Now we are going to talk about molarity. What is meant by molarity? Molarity is a second way or a second qualitative method for expression of concentration. So what's meant by molarity? Molarity is expression of concentration. It means number of moles of solute in liter of solution. In liter of solution. What's meant by molarity? Molarity, it's a way of concentration that express the number of moles of solute in liter solution. So, can we express it in a mathematical method? Then molarity, or capital M, it equals to the number of moles of solute in liter solution, or divided by liter solution. Molarity, which is capital M, it's equal to number of moles of solute divided by liter solution. Molarity can be expressed in the form of capital M or mole per liter. Mole, M-O-L-E, per liter. Mole, it means here the number of moles, and we expressed before in the previous slide that mole is the molecular weight of substance in gram. Here, molarity again is a source or a way of expression of concentration. It expressed the number of moles of solute in liter solution. Molarity, capital M, equal number of moles of solute divided by liter solution. It can be expressed in capital M or mole per. Here, what about 1 molar solution? 1 molar solution, it means it is the solution that contain 1 mole of solute dissolved in 1 liter of solution. So, what's meant by 1 molar solution? It is a solution that has 1 mole of substance dissolved in 1 liter of solution. Can we express it mathematical? Yes. 1m equal 1 mole per liter. 1 mole, M-O-L-E, per liter. It means that 1 mole of substance present in 1 liter of. What about dilutions? Dilution, it means that making a solution that is of lower concentration. What's meant by dilution? Dilution, it means that I'm going to make a solution of less concentration or lower concentration. How I get lower concentration? To get lower concentration, we shall to add more solvent. We shall add more solvent. Here in these 2 beakers, the first one or the first beaker, here it is darker in color, and we mentioned before that dark color, it means that it is highly concentrated. In another way, it means high amount of solute. So high amount of solute will give high concentration, will give deeper in color or darker in color. To make this solution is diluted, I am going to add more water. Or add more solvent, then the amount of solute will be decreased. By decreasing of amount of solute relatively to the amount of solvent, then the solution will be diluted. Here, look for this scope. Here in the concentrated one or solution number A, here the blue dot, it is the solute particle. The blue dot will be the solute particle. By increasing the solute particle, it means that it is highly concentrated. For solution number B or the diluted one, the solute, which is blue, become less, and the solvent, which is red, become increased. Then by increasing the amount of solvent, I'm going to decrease the concentration or lower the concentration. Look here for beaker B. Beaker B is paler in color. Paler, it means that it is more diluted or less concentrated. Less concentrated, it means that the amount of solute is decreased and amount of solvent is. What will be the example that will be given in the exam? And how to calculate concentration of a solution after dilution from stock. how to calculate concentration of solution after dilution from stock. Here I have an equation which is CIVI equals CFVF. CI, it means that the initial concentration. C is for concentration, V for volume, I for the initial initial concentration or initial volume. I is initial. Initial, it means the stock that is stored in our lab. It is the stock. F, it means the final volume or the final concentration. CF, it is the final concentration. VF, it is the final volume. The final, it means that the prepared or the diluted one. Again, what is the equation for dilution or to calculate of dilution from stock? CIVI equals CFVF. CI, concentration of initial or the stock, multiplying by VI, which is the volume of the stock, equal CF, the final volume or the diluted concentration. CF is the diluted concentration, and the VF, which is the volume of the diluted or the final volume. VF, it means the final value of the final volume of the solution. Final volume of the solution. We have an example. How many liters of 5.5 molar sodium hydroxide are needed to prepare 300 milliliter of 1.2 molar sodium hydroxide? Here, before I go to answer, I have to know which is the stock or which is the initial and what will be the final or the diluted one. Preparing 300 milliliter of 1.2 molar, 300 milliliter is the final volume or VF, and 1.2 molar is the final concentration. So CF will be 1.2 molar, which is concentration, and VF will be 300 milliliter. So what about CI and VI? CI is the concentration of stock, and we know that concentration is expressed in molarity. So the concentration of stock is 5.5 molar. Here, what is the unknown? The unknown will be the volume that I'm going to get from the stock, which is VI or the initial volume. The amount of volume that I'm going to take from the stock. So how I'm going to solve it? Then I'm going to write first the equation CIVI equals CFVF. Then CI is replaced by 5.5 and VI, that is unknown, equal to 1.2 molar multiplying by 300 milliliter. Then V1 or VI equal 1.2 multiplying by 300 divided by 5.5. Then V1 will be 65 milliliter. It means that I'm going to take 65 milliliter of the stock of 5.5 molar. How to get 300 milliliter? I'm going to add water to the 300 milliliter to get the 300. The final volume 300 milliliter. I'm going to add milliliters after 65 to get 300. The last one in expression of concentration, which is the dilutional factor. What is dilution factor? Dilution factor is a ratio. This ratio between the final volume to the original volume. In the exam, I'm going to ask you what is the dilutional factor. Then dilutional factor, it means what? The dilutional factor, it is the ratio between the final volume to the original volume. Again here, the dilutional factor equal final volume divided by the original volume. Shall we have an example? Here, if 10 milliliter of blood are completed 200 milliliter with saline. 10 milliliter of blood are completed 200 milliliter of saline. So, what is the dilutional factor? First, I have to determine what is the final volume. Here completed 2, this is the final volume. The final volume is 100 milliliter saline, 100 milliliter saline. So what about the original volume? The original volume here is 10 milliliter. The original volume is 10 milliliter. By dividing 100 milliliter by 10 milliliter, I get 10. Then the dilutional factor will be final volume, which is 100, divided by the original volume, which is 10. It will give 10. Then the dilutional factor will be 10. Now I'm going to know how to measure volume in glassware. First, water in glassware or in glass cylinder have surface tension. The surface tension of water make it act like a meniscus. Water in glass cylinder, by its surface tension, it will get a meniscus. It will give a meniscus. How to calculate the volume of water or water solution in cylinder? From the meniscus, the apex of this meniscus, I have to take a line. This line must be tangent with the reading of the cylinder. Again, water in glass cylinder make a meniscus. So how I can get the volume from this meniscus? The apex of this meniscus, I have to take a line tangent to the number. This will be the reading. Shall we have an example? Here in cylinder number 1, what is the volume of water or solution present in cylinder number 1? Here the meniscus. So I have take line tangent from the apex and make it coincides with the number present on the cylinder. First, between 10 and 20, here are 5 lines. Then every line is represented by 2 marks. Then the line after 10 will be 12, then 14, 16, 18, and 20. Then here this meniscus, I have a take a line from the apex of this meniscus. It will coincide or it will be tangent with this line above 10, and it will be 12 milliliter. Then the first cylinder will be 12 milliliter volume. Here in cylinder number 2, what will be the measurement of this volume? First, I'm going to look to the meniscus. Here the meniscus, and from the apex I have a tangent line. This tangent line coincides with, yes, this 15. The line for above 15, it will be 16. Then number 2 contains 16 milliliter. For cylinder number 3, here the meniscus, the apex, I'm going to have a tangent. Then between 10 and 20 are 5 lines, then each one represents 2. Then here is present in the second line above 10, then it will be 14 milliliter. Yes, that's right, it will be 14 milliliter. In the last one, or cylinder number 4, what will be the volume? Here the meniscus, from the apex I have a tangent. This tangent coincides with, yes, 14 milliliter. 14 milliliter. We have finished expression of concentration. Again, what about our concept map? This time we are going to express pH and buffer. pH and what will be the ILOs? We are going to define acids, bases, and the neutral solution. We have to observe general properties of acid and bases, differentiate between strong and weak acid and bases. We have to define pH, pOH, and pKa. We have shown to measure the pH of solution of acids or bases, describe how the indicator work, explain the action of buffer. First, what are acids and bases and what are their properties? Acid, its taste is soury. Acids taste soury, like lemon, like orange. Then acids taste soury. What about the effect of acids on litmus paper? The blue litmus paper will be turned into red. The blue litmus paper will be turned into red. What about the definition of acids? Acids means that they are hydrogen donor. Acids are hydrogen donor. Hydrogen donor. It means that they liberate hydrogen when they are present in water. Again, what about acids? Acids, they taste soury, they turn blue litmus paper into red, they form hydrogen ion when present in water. What are examples of acid? Here, strong acid as HCl and which is hydrochloric acid, and sulfuric acid, which is H2SO4, and acetic acid. What about bases? The taste for bases is bitter. It is bitter. What about the action of litmus paper? In base, the red litmus paper will turn into blue. Blue, the first letter, which is B, B for bases, B for bases. Then, when the red litmus paper turns into blue, blue is for base. So, what is the action of bases, or what is the definition of bases? Bases, these are substances which are liberate hydroxyl ion in water. Liberate or give hydroxide ion in water. Can we give examples for bases? Bases are like sodium hydroxide and ammonium. Again, bases, they are taste bitter, they turn red litmus paper into blue, they form hydroxide ions in water. Example for it are sodium hydroxide. Is it better to express the measuring of acidity or alkalinity in hydrogen ion concentration or pH? Shall we see it here? The hydrogen ion concentration in moles per liter, which is 1, 0.1, 0.01, 0.0001. This is different zeros. And here is the hydrogen ion concentration is very, very, very small. Can we calculate the pH, or can determine or measure the acidity or alkalinity by these very large fractions or very, very small fractions? So it is very difficult to express the measuring of acidity and alkalinity from the hydrogen ion concentration. So we have replaced these very small fractions by the pH. pH is a logarithm relationship between hydrogen ion concentration. So we get a logarithmic relationship between pH and hydrogen ion. So what is pH? pH is the negative log of hydrogen ion concentration. Negative log of hydrogen ion concentration. So when I ask you how I'm going to measure acidity, acidity and alkalinity will be not expressed in hydrogen ion concentration, as the hydrogen ion concentration is very, very small, and it is have different fractions and different decimals. So by expressing it in pH and pOH, it will be easy in measuring. What is the relation of pH or pOH? It is a logarithmic relation. A logarithmic relation. Here, when I am converting this decimal to solid number, here 0.1, it means that it is 10 to the power negative 1, and 0.01, it means 10 to the power negative 2, and here 0.001, it is 10 to the power negative 3. So what will be the logarithmic relation? 10 to the power negative 1, it means log 10 to the power negative 1, it means that it is 1. And when get log 10 to the power negative 2, then it will be 2. So here the numbers are having no decimals, or they are whole numbers. This whole number is easy or better for measuring acidity and alkalinity. Again, to express the acidity and alkalinity, I shall have the pH or pOH, which is the logarithm relation with the hydrogen ion or hydroxyl ion concentration. So pH is used to measure the acidity or alkalinity of an aqueous solution. pH equal negative log of hydrogen ion concentration, and pOH the negative log of hydroxyl ion concentration. Now, what about the pH scale? pH scale ranges from 0 to 14. From 0 to less than 7 or less than 7, it is acidic. Less than 7 is acidic. 7 is neutral, or equal to 7 is neutral. More than 7 till 14 will be basic. Then the range of the pH scale from 0 to 14. Less than 7 will be acidic, equal to 7 is neutral, more than 7 will be basic or alkaline. Again here, from 0 to less than 7 is acidic, from more than 7 to 14 will be basic, and equal to 7 will be neutral. Now, what is the difference between pH and pOH? pH is the negative log of hydrogen ion concentration. pH equal negative log of hydrogen ion concentration. And what about pOH? It is the negative log of hydroxyl ion concentration. pOH is negative log of hydroxyl ion concentration. As pH measure the hydrogen ion concentration, pH measures the hydrogen ion concentration, so it is the relation between the negative log of hydrogen ion concentration, and pOH, it measures the hydroxyl ion concentration, so there is a relation between pOH and the log of OH. For any solution, it's found that the sum of pH and pOH is equal to 14. And any neutral solution like water, the pH equal to the pOH and equal to 7. Again, pH plus pOH equal 14, and in neutral solution like water, the pH will be equal to pOH and equal to 7. Shall we have a problem solving? What is the pH of hydrochlorine solution with hydrogen concentration 10 to the power negative 1? Here, what is the relation between pH and the hydrogen ion concentration? Yes, pH equal to negative log of hydrogen ion concentration. Then pH equal negative log 10 to the power negative 1. Then it is 1. Then the pH of this solution will be 1. Here, negative log 10 to the power negative 1. Then I'm going to have it 1. Another problem solving. What is the pOH of hydrogen or hydrochloric acid solution with hydrogen concentration 10 to the power negative 2? Here he asked about the pOH. pOH, it is expressed in the negative log the hydroxyl ion concentration. Here, this solution is acidic and it contains hydrogen ion, not hydroxyl. So, I'm going to get first the pH. The pH for HCl or hydrochloric acid will be 10 negative log of 10 to the power negative 2. Then the pH will be 2. What about the pH? I know in an equation that pH plus pOH equal 14. Then when I'm getting the pH, which is 2, then pOH equal to 14 minus 2, and the answer will be 12. Again, the answer will be here, hydrochloric acid is an acid and it has hydrogen ion concentration, but pOH represent hydroxyl. So I'm going to get the pH first. pH equal to negative log of the hydrogen ion concentration, which is 10 to the power negative 2, and the pH will be here 2. So it is easy to get the pOH. pOH plus pH equal 14. Then to get pOH, then 14 minus pH, which is 2, then 14 minus 2 equal 2. 14 minus 2. Another problem solving. What is the pH of a potassium hydroxyl solution with hydroxyl ion concentration 10 to the power negative 4? Again, pH, then it's a relation between hydrogen ion concentration. Here, this substance is potassium hydroxide. Potassium hydroxide containing hydroxyl ion. Then, from potassium hydroxide, I'm going to express or to calculate pOH. Then first, I'm going to calculate the pOH. POH equal to negative log للهيدروكسيل ion, and here hydroxyl ion is 10 to the power negative 4. Then POH equal negative log of hydroxyl ion, it is equal to negative log 10 to the power negative 4, and it is 4. So what about the pH? Again, from the equation that told the pH plus POH is equal to 14. Then pH equal 14 minus 4, it will be. How we are going to measure the pH? pH also again will be measured in two methods, qualitative and quantitative. Qualitative, it will going to mention if this solution is acidic or alkaline or neutral. It will give no value, it give no expression of numerical value. So the qualitative method, for example, chemical indicators and litmus paper, it will express whether it is acid or base or neutral. But what about quantitative? Quantitative, it will be expressed in numerical value. Here the numerical value can be got through the pH meter. This is the pH meter. This is a pH meter. It is an instrument. It's an instrument that use a power supply or electricity to get the pH in a numerical value. Here, did you see the number or the digital number present? This is the quantitative method. Quantitative, it gives numerical value. So the pH meter, it determines the pH of a solution through measuring the voltage between these two electrodes that are present in a solution. As pH is numerical, so it is more precise. Now we are going to take the other qualitative. Qualitative, it means that it will get acid or base or neutral. And for qualitative method, I have to form indicators, which is chemical indicator and litmus paper. Indicator or chemical indicator, these are compound. This compound just change its color when it's contact with acid or base. Then chemical indicator, these are colored solution, or these are solution. This solution will change their color when they are in contact with acid or base. This indicator present in the form of methyl orange. This is one indicator, methyl orange, and the other one is phenolphthalein. And then indicators, these are substances that change its color by adding acid or base. What are the examples of chemical indicators that we have? We have two examples. One is methyl orange and the second one is phenolphthalein. The second method for qualitative measuring of pH, it is the litmus paper, and we have mentioned that when the litmus paper, the blue one, turns red, then it is acidic. When the red one turns blue, B for basic, then this solution is base. When the red and the blue one not changes, then it will be neutral. Then the solution will. About the chemical indicator, I have an example which is methyl orange. Methyl orange, its range is from 2.9 to 4. 2.9 to 4. Then, when an acidic solution or a solution of pH less than 2.9, then the methyl orange have a color like the iodine, slightly orange in color. Methyl orange, its native color is like slight orange. The range of methyl orange is 2.9 to 4. 2.9 to 4. When methyl orange become in contact to a solution that is in pH less than 2.9, it will turn into red color. And when it is in contact with solution of pH more than 4, it will be yellow in color. Here, in the picture below, the middle bottle contains methyl orange. Look for the dropper. Here, the native color of methyl orange, which is slight orange. When this methyl orange added to acid, and this acid, its pH less than 2.9, or it's added to a solution, its pH less than 2.9, then it will give a red color. When the methyl orange is added to a solution that its pH more than 4, it will give yellow color. Here, beaker number B containing solution that its pH is more than 4. Indicator, which is the phenolphthalein. Phenolphthalein. The range of indicator of phenolphthalein is 8.3 to 10. Then when it is added to a solution less than 8.3, then it have no changing in color, no color change. When phenolphthalein is added to a solution that pH is less than 8.3, then it will give no color change. طب, what about phenolphthalein when it is added to solution of more than pH more than 10? When phenolphthalein is added to solution of pH more than 10, it will give purple color. Purple color. Here, this is the phenolphthalein, and beaker number 1 has pH less than 8.3 and show no change in color. Show no change in color. Here, in beaker B, when I'm going to add phenolphthalein, it got purple color. When I'm going to add purple color, and when I'm going to add phenolphthalein to this solution and it turns into purple, when this solution turns into purple, it means that the pH of this solution is more than 10. And when I'm going to put the phenolphthalein to a solution and no color will be changed, then the pH of the not changed color is less than 8.3. Less than 8.3. Now we are going to have the last topic in pH and buffer, which is buffer. What is meant by buffer? Buffers, they are compounds that resist changing in pH of a solution when I'm going to add small or moderate amount of acid and bases. Again, what's buffer? Buffer, these are compounds that resist change in pH when I'm going to add small amount of acid or bases. What is the composition of this buffer? How can buffer resist this pH? Buffer is composed of either weak acid like carbonic acid and its salt of strong conjugate base. Salt of strong conjugate base, which is sodium bicarbonate. Then buffer is composed of either weak acid and it's the salt of its strong conjugate base, or it is formed of weak base with the salt of strong conjugate acid. For example, the weak base is sodium nitric hydroxide, or nitric oxide, nitric hydroxide, nitrate hydroxide. Yes, the weak base is nitrate hydroxide, and its salt with strong conjugate acid is nitric chloride. So, how buffer resists? Buffer is composed either from acidic part and basic part. Acidic part and basic part. And we mentioned before, acid, it means that it is proton donor, and base are hydroxyl donor, or it is proton acceptor. Bases are proton acceptor. When buffer is composed of part acidic and part basic, by adding acid, when I'm going to add acid externally, this acid will liberate hydrogen. The hydrogen liberated will be accepted by the basic part to make resist. For this reason, buffer is composed of both substances, acid and base, either weak acid and its strong conjugate base, or weak base with its strong conjugate acid. Why? Again, I have a buffer and I'm going to add an acid. The acid added is proton donor, then hydrogen ion will be increased in the solution. So What is the role of buffer? Here, the buffer by its basic part is going to accept hydrogen. So it will resist the change in pH till a limit, or by adding small amount. If I'm going to increase, this buffer will be consumed, and no part, or no the basic part will not accept more hydrogen ion. If I have a buffer and I am going to put base is proton acceptor, then it will accept the hydrogen from the solution. So the buffer by its acidic part will liberate hydrogen or give hydrogen to the solution in order to make balance in the solution. This is buffer. What is buffer? Again, buffer, it's a substance that resists change in pH by adding small amount of acid or base. Why? Buffer is composed of two or both sides, weak acid and the salt of its strong conjugate base, or it is formed of weak base and the salt of its strong conjugate acid. What is the importance of this buffer? Buffer is important in order to keep the pH for enzymes to work. We know that enzymes have to have optimum pH. This optimum pH makes this enzyme act well. By changing this pH, then this enzyme will be denatured, or the pH will be changed and this enzyme can't work well. Then what is the importance of buffer? Buffer is important in order to correct the pH for enzyme to work. So any disturbance in the buffer system, it leads acid imbalance or changing in pH. Changing in pH will destroy the enzyme and will stop the enzyme from working. By stopping the action of enzyme of our body, this will lead to fatal disease or may lead to diseases. Then buffer is important to correct the pH. pH is important for the optimum activity of the enzyme. By disturbance or problem in this buffer system, the enzymes will be denatured and stop working, leading. What are the examples of physiological buffer in our body? Our body containing physiological buffer in order to correct the pH. What are these buffers? I have carbonic bicarbonate, which is the most important buffer system in the body. The second one, which is phosphate. Third one, which is plasma protein, hemoglobin, and free amino acid. Again, what are the physiological buffers in our body? I have phosphoric and phosphate, carbonic acid and bicarbonate, which is the most important one. I have plasma protein, I have hemoglobin, and I have free amino acid. What will be the example in our lab about buffer, or what will be the problem about buffer in the lab? Here in picture A, I have two beakers. These two beakers were treated with methyl orange. I know that methyl orange, its native color is orange, but when I'm going to add pH more than 4, it will give yellow color. Then here in these two beakers, they have the same pH, which is 8, and 8 is more than 4, and it gives yellow color. But one of these beakers have buffer. Buffer means that it will resist the pH, and second one has no buffer. Here the yellow one in picture A on the leftmost side is unbuffered or has no buffer, and the right yellow one in picture A, it containing the buffer. What will be the effect by adding acid? In picture B, I have to put 2 drops of acid in the unbuffered one and 2 drops of acid solution in the buffered one. I know when buffer is present, it will lead to resist the pH. Here, after adding the 2 drops of acid, In both beaker, the unbuffered one have changed its pH. How I'm going to know that this is changed? I use the methyl orange by adding acid to it, or when the pH is less than 2.9 it will turn it into red. But here in the beaker containing the buffer, it resists the pH. It maintained the pH in its normal range. How I could know? I could know as the methyl orange not changed its color. Then how I'm going to know which beaker contain the buffer? The beaker that resists the pH or resist the pH and not change its color, it will contain the buffer. But the beaker that will change its color early and very easy, that is the unbuffered one, or the beaker that contain no buffer. We have finished our second part of practical in biochemistry module. Thank you very much. I hope that you get it well. Thank you and good luck, doctors.